Hello everyone, this is Dr. Young here, and in this short video I'm going to talk to you about what disaccharides are, give you an example of the three most common ones, and we're going to start talking about glycosidic linkages, right? What does it mean to say that something is beta 1,4, alpha 1,6, etc.? So three main diglycerides, much like I was saying with the monoglycerides, there are a ton of diglycerides out there. There's many forms. I only care about these three because they're three really common ones. So we've got sucrose, lactose, and maltose. Sucrose you may have heard of more commonly. It's just sugar. When people say add a cup of sugar to a recipe, that's what we're talking about. That's this, the white stuff that people like to put in their coffee, put in drinks. So it's just good old table sugar. And sucrose primarily for us comes from just two plants, either your sugar beet or your sugar cane, which is kind of crazy to me. Just two species of plants. Actually, there may be subspecies, but basically two plants. And you get sucrose when you take one glucose and you combine it to a fructose. So you're going to take a glucose and we're going to combine it to a fructose. And when those two things combine, when they link together, that's what we call sucrose. That would be a disaccharide, right? Because if you look at the word disaccharide, di meaning two, and then saccharide again meaning sugar. So disaccharides are literally two sugars that are linked together. Another common disaccharide that you probably have heard of is lactose. You may have heard of people being lactose intolerant, for example. That's also known as the milk sugar, right? So we're talking about milk as in mammal milk. Lactose is not in non-mammalian milk, as in it's not in almond milk or coconut milk or anything like that, right? We're talking about mammals. We're talking about what we would call breast milk or cow milk or goat milk, something like that. And lactose is made out of a glucose attached to a galactose. And that's pretty easy to remember because galactose has the word lactose in it. And glucose is in everything, basically. It's the most common monosaccharide. So remembering that lactose has glucose and galactose in it should be hopefully not too terrible. And then lastly, the other big disaccharide I want you to know is maltose. And that's considered a grain sugar, right? That comes from grains like wheat and barley and stuff like that. And you may have heard of malt. Right, if people talk about malt beverages or like malted milkshakes or malt balls, right, like Whoppers or something like that, that malt flavor, which I love, that malt flavor is from maltose primarily in the small maltose. And that's just combining two glucose molecules together. That's all we're talking about. And so I have that drawn out down here to give you more of a visual idea of what these disaccharides look like here. Right, so on the left-hand side, I have an alpha glucose. Right, because the OH is sticking down, and here I have a beta glucose. Let me erase this. I have a beta glucose. I know it's beta glucose because I have the OH sticking up. Oh, I can't spell glucose right now. That's what I get for talking and writing. So beta glucose. And remember, I don't remember if I said this in the last video, but you can remember alpha glucose, alpha, because it looks kind of like a fish. And fish live down in the water. And beta, I had a student tell me that she thought that beta kind of looked like a butterfly. So beta is like a butterfly. And butterflies fly up in the air. Fly up in the air. So you can remember that, the beta looks like a butterfly, flies up in the air. Alpha looks kind of like a fish. Fish live down in the water. Or you can remember it by the way you write them. People tend to be on a downward swing when they start writing an alpha and an upward swing when they start writing beta. So however you want to remember it. But I've got two glucose molecules here, right? I got glucose on the left, glucose on the right. Just like we said in other videos, right? Whenever we're taking these subunits and we combine them, right, to make a macromolecule, we're always doing the same reaction, which is condensation. So remember in condensation, I just need to find an OH on one molecule and a partially positive hydrogen on another one. If I look at these two glucose molecules, there are a ton of OHs, right? Each one of these has 5 hydroxyl groups on it. So there's a lot of different ways that I could combine them. I could combine any pairs of these OHs to each other. For maltose specifically, it's going to be this OH and this H. Those are the two that are going to connect. And so when those two connect, I'm going to make water. And then I'm going to link them at those two spots. And let me number those spots so we can have a common language here, right? So this is carbon, remember 1, 2, 3, 4, 5, and 6. Carbon 1, 2, 3, 4, 5, and 6. And if I put those numbers back over here, we can see that we've attached, right, carbons number 1 and 4. 3, 4, 5, and 6. Now, when we're talking about what type, when we attach these two things, right? So over here on the right-hand side, this would be your maltose. So I took my 2 glucoses and then I connected them to make maltose. And what's really important about maltose is the type of linkage that it has. Like I was just saying, right, with the 2 glucose molecules, I could have picked any 2 of those OHs really to do a condensation. I could have just picked like a ton of them. However, maltose specifically is only this molecule, only when we have this type of linkage, right? This what's called a glycosidic linkage. Glycosidic linkage, and that's when you link 2 sugars together, 2 monosaccharides together. It's called the glycosidic linkage. And these glycosidic linkages have names, like I was saying before, like alpha 1,6 or beta 1,4 or something like that. And to name this, right, first I want to know what was going on at carbon number 1. Was that OH going up or going down? And if you take a look at it, right, this O looks like it's going in the downward direction, right? We have an OH going in the downward direction here. And remember, when it's moving in a downward position, we said that that was alpha. So that means this is an alpha linkage, not a beta linkage. A beta linkage would be heading upwards, and I'll show you more examples in the next slide. So we want to know, is it alpha or beta at that anomeric carbon at carbon number 1? Was it moving more up or down? In our case, down. And then we also want to know what carbons were attached to one another. So did I connect carbons like 2 and 4, or 1 and 3, or 1 and 6, or 2 and 4, or 1 and 1, or what ones together? And for us, it looks like 1 was connected to 4. So carbon 1 of the first glucose is now connected to carbon 4 of the second glucose. So I have what's called an alpha 1,4 linkage. And you'll see it written like that, like alpha, or you could see it written like 1 to 4. There's a couple of different ways you can see it, but you're going to see alpha and a 1 and a 4 somewhere in there. And that's really important because maltose is glucose when they're connected with an alpha 1,4. It's not maltose if it's connected any other way. It's some other sugar. So let's take a closer look at determining these types of bonds. Now, ideally, I would like it if you pause for a sec and see if you can name any of these, right? So you want to look at the numbers on the carbons, and are you moving up or down at those individual spots? So I'm going to go ahead and number a whole bunch here. So 1, 2, 3, 4, 5, and 6, right? Carbons 1, 2, 3, 4, 5, 6. You'll notice that I'm doing this the same for all of them because that's the convention that we use for these Haworth projections. That's what you're going to see. And that carbon number 1 that I'm linking was the aldehyde for these glucose molecules. And so I indicated with these arrows, I want to know what the linkages are at each one of these arrows. And so if I take a look at my first arrow, right, I want to know at carbon number 1, am I moving up or down? It looks like at carbon number 1, I'm moving in a downward direction, so that would definitely be alpha. And I'm connecting carbons 1 and 4, so that would be an alpha 1,4, just like the linkage we saw in the first one. If I go to this second one here at carbon number 1, it looks like my my oxygen at carbon number 1 is moving up, and it's connecting carbon number 4. So if it's moving up, then that's a beta, right? That's the beta anomer, that's the beta form of glucose. And it's connecting carbons 1 and 4, so that'd be a beta 1,4 linkage right there. If we go over here to the right, it looks like we have another alpha 1,4, so this would also be down, also connecting 1 and 4. So this would be another alpha 1,4. If I move up here to the top right-hand side at carbon number 1, I'm moving down, so that's a beta. Oh, sorry, I'm moving down, so that's an alpha. Moving down, so that's an alpha. And now I'm connecting carbon 1 to carbon 6. That's kind of a tricky one because it looks a little different. So I'm connecting carbons 1 and 6, so that's an alpha 1,6 linkage. And then lastly, if I go down here to the right-hand side, looks like my carbon number 1, I'm heading upwards at carbon number 1, so that'd be a beta. And it's connecting carbon number 2, so that'd be a beta 1,2 linkage. And so it's really important that you're able to identify what these different linkages are because that's going to help us decide what type of, for example, polysaccharide we have. Is it connected by alpha 1,4s or beta 1,4s? Because what you'll see, like I was saying before with maltose, is that just because it's 2 glucose molecules doesn't mean it's maltose. It has to be connected in the right way. So like if you look, for example, on this particular sheet, I just took this from Wikipedia. It has a whole bunch of links of the disaccharides. The web address is down there on the bottom right if you want to go take a look. We just said, right, that maltose is 2 glucoses connected with an alpha 1,4. That's exactly what we said, right? Alpha 1,4. However, if you take a look at this, right, it looks like also if you have 2 glucose molecules, you could connect them alpha 1,1 alpha, and that's apparently something called trihalose or something. If you take 2 glucoses, you connect them beta 1,4, now that's cellulobiose. And then there's all these other ones down here. Look at all of these that are just 2 glucose monomers, and this one down here. All of them have different types of bonds, right? Alpha 1,3, alpha 1,6, beta beta, beta 1,2, and they all have different names. They're all different disaccharides. And so you can make a whole bunch of different disaccharides, and we'll see polysaccharides, depending on how you connect the different pieces. And this is just with glucose. If you scroll down on this page, you'd find what happens if there's all these different ways you could combine fructose and glucose, or glucose and galactose, or galactose and fructose, etc. So the type of bond is really important. So you want to be able to identify one. I'm flat out going to ask you to identify bonds for me in my class. So I hope that gives you a little better idea of what a disaccharide is, the 3 main ones that I want you to know. I want you to know just general information about them and how to identify what type of glycosidic linkage you have. That's a very important piece. So if you have any questions or comments, please leave them down below. Happy studying!